Hello. Section 6.2, we're going to cover transforming and combining random variables. Um, we're going to just build on the work that we did last section with discrete and continuous random variables. So we're going to talk about rescaling, shifting, and how it affects that. So what's the best way to do this? Okay. So let's say that, all right, yeah, I like this. All right. So we have this discrete random variable, number of passengers that go on Pete's Jeep tours, 2 through 6, probability of each. We have mean, we have a standard deviation. So if we think about the shifting and the rescaling, transforming this discrete random variable, say we know each ticket is $100, but he has $20 in expenses, like for gas and for like equipment rental for the people. So here's what I know. I know the expected value is 3.75 passengers, and the standard deviation of that is I'm just going to round 0.9 passengers. So essentially, I'm going to take this equation and look at his profit. Well, his profit is 100 times every person that goes minus the $20, because the $20 he's paying gas for the vehicle and, like I said, equipment rental. So what I'm really going to be asked to do is now find the mean of the profit and the standard deviation of the profit. So this is like what we saw a couple chapters ago. I have a rescale and a shift. Mean is a measure of center, standard deviation is a measure of variability. For the measure of center, it's affected by the shift and the rescale, both. So 375 minus 20, the new mean would be $355. I believe if I did that math right. And the new standard deviation, it's only affected by the rescale. So it's only going to be affected by this multiplying by 100, not the adding and subtracting of the $20. So this ends up being $109 for the standard deviation. It's not always going to be this easy because there's going to be context around it that you're going to have to extract. Like they're not going to just come right out and tell you this, that obviously most likely, but that's in essence what's happening with the discrete random variable with your transformations, your shifts and your rescales. So then we got into this idea of combining random variables. And so you have Pete's Jeep tour, and so this is Pete's Jeep tour, and then I think in the book you had like Aaron's airplane tour. I don't know, I'm stretching here. So let's say the mean for her, I don't know why I chose E. Let's say she averages 2.7 passengers in her helicopter, and her standard deviation is like 0.9 passengers. So now what we might be thinking is like, all right, what is the total amount of passengers we would expect Pete and Aaron to have during a randomly selected day? So really, I want the total. That's going to be Pete's number of passengers plus Aaron's number of passengers. So for the mean of the total, means play nice, you've heard me say it. I'm just going to sum up the totals for each of the means. But for the standard deviations, we learned that the standard deviations don't just add, the variances add. So I take Pete's standard deviation, square it. That makes it the variance. I'm going to take Aaron's standard deviation and square that to turn it into the variance. That will give me the total variance. I want the total standard deviation, so I'm going to take the square root of that, whatever that equals, is going to be my total standard deviation. We also looked at what if we were looking at how many more passengers we expect Pete to have than Aaron. So let's call this D for difference. So the mean difference would just be the difference between the means. That's it. Means play nice. Standard deviations. This is adding in extra variability. We have the variation for how many people show up for Pete's Jeep tour and Aaron's airplane tour. So it's going to be the same exact calculation for the standard deviation as it was for the sum. We always add variances, never subtract. We have more than one independent random variable, we're going to add that variance in, whether it's a sum or a difference. Taking this a step further, now say we're looking at the total cost. And say, again, Pete's tickets are $100 a piece, and Aaron's tickets, let's say, are $150 each. And I want the total cost, so I'll say TC. So Pete would be 100 times his number of passengers plus Aaron's 150 times her number of passengers. 2.7, that looks like a 27. Means are affected by rescales. Standard deviation of the total cost. So the new standard deviation would be 100 times the 1.09. That's the new standard deviation. Standard deviation is affected by rescales. But I need the variance, so I'm going to square that. Same idea for Aaron's, 150 times the 0.9, and that's squared. And I'm summing that up. I'm always adding variances. So that pretty much goes through all the different types of situations that you're going to see when it comes to random variables and shifts and rescales. You have to have independent random variables in order to add the variances. That's true. For the means, it doesn't matter. You can do whatever. We talked about that. That's adding variances. Means play nice. Okay, yep. Variance, yeah, mean of the difference. Doesn't matter. Okay. Now when we get to continuous random variables, it's going to work the same way. If I want the mean sum, I'm just going to add the two averages. And the distributions, if they're both approximately normal and I add them, they're going to be approximately normal. If I multiply them, they're still going to be approximately normal. Divide any operation, it's going to stay the same. So the mean of these two distributions, one was 3, one was 1, so the total mean would be 4. The difference, I'd just subtract them. The spreads are going to be exactly the same because we always add variances. So whether we're dealing with continuous random variables or discrete random variables, the rules are going to be the same. Now, this is a great question because it looks like you only have one random variable. So we have Mr. Starnes, he likes sugar in his hot tea, and he puts in, let's see, he needs between 8.5 and 9 grams of sugar in a cup of tea for it to taste right. So he adds 4 randomly selected packets of sugar. So that's one random variable, but the 4 packs are each independent of one another. So you'll notice here they did t equals x1 plus x2 plus x3 plus x4. Each of those represents the amount of sugar in one of those packets. So the total, means play nice, just add up the total. The mean of each bag is 2.17. Add that up 4 times. Standard deviation, I'm going to have to add the variance 4 times and then take the square root of that. So now I have this continuous random variable where for the 4 packets, it has a mean of 8.68 grams and a standard deviation of 0.16 grams. And now I can answer this question, what's the probability that he's going to have between 8.5 and 9 grams of sugar, which means his tea tastes just right. So a couple z-scores, a couple normal CDF calculations, and that's going to give you your probability. But you have to understand how to set that up. This is just another example. We did this one in class with the size of the lid and the size of the cup as far as figuring that out. But again, it's the extracting the information from the question, in my opinion, that makes it difficult. Once you get to the calculations, those are pretty straightforward. Means play nice, do what the formula says, standard deviations. You always add the variances. And I think that's it. Yeah, that's it for section 6.2.